Yeah, dude, it's awesome to meet you. I'm really excited about Ivy. I've been diving into the renaissance of AI recently because I got fascinated by AI in 1989. And then when
Real
I
old school.
graduated in 94, nobody wanted to hear about it. They're like, do you know C? I'm like, I know Lisp. They're like, what the hell is Lisp?
It's
Like,
very
if
much
you
kind of one of
can
the
get through
AI
this C++
winters.
book in 2 weeks, then we'll give you a job.
Yeah, yeah. No, I actually
So
I
this
remember
this
what.
this rebirth and renaissance is pretty cool.
Yeah, I remember when I first started getting into neural networks. Actually, I was watching a lot of lectures and things from back in the kind of late '90s and early 2000s, and it seemed incredibly niche back then. Another thing as well, just sorry, a bit off topic. I hope that's okay, but I noticed a few guitars in the background.
Absolutely. The only topic is that like we've got two enormous nerds talking with each other and a bunch of people who want to overhear.
Also guitar notes, it seems, because I actually used to be in a few bands, and I've got like a few guitars in my room, so I think maybe the creativity of music and the creativity of coding perhaps overlap a bit. But yeah, very nice to see that in the background. But yeah, no, what I was
Now I
saying.
want to hear about your guitars.
Yeah, well, so it's going to be an hour long of guitar. Otherwise, the funny thing is, kind of very quick story on that is basically that when I was a teenager, very much into the whole pop punk era. So when I was like 11, 12, we were in a band. I had myself a Paul Reed Smith because that's what Linkin Park had. We were there doing Green Day, Blink-182 covers and all this kind of stuff. And we did like little kind of battle bands and acts around the
PRS for
hall.
punk.
Yeah, yeah. Paul Reed Smith. Well, it was kind of metal a bit because it was Linkin Park. And I remember when Hybrid Theory came out and the Meteora, their guitarist had this Paul Reed Smith, and I wanted that
Oh,
exact
sure.
one.
Oh my God. Yeah, the world
Um,
stopped when those albums came out.
No, exactly. So I was kind of a bit of a metalhead originally, then kind of went into pop punk with the whole kind of fad with Blink-182 and stuff, and then became a bit of an indie person with the kind of British indie wave. But unfortunately, what I then noticed, I say unfortunately, but then when I started my degree in engineering at the age of 18, everything then quite quickly became very much work focused. I'd kind of before been in various bands. I played a lot of football, played a lot of rugby. Then when I started at Imperial College, the workload was pretty intense and kind of ended up saving it for the weekends. And as time's gone on, I think the creative juice that I used to apply to writing songs, I'm then quite thankful that I feel like that has kind of shifted. And let's hope this stays the case. Like it still does to this day. I still find that like creative hobbyist outlet in software engineering, actually, in the coding. And I think kind of I managed to reapply that stuff. So I think there are some overlaps because I think coding is it's very technical, but I think it's also got a very creative exploratory side that overlaps with a lot of the arts as well. At least that's how I justify my kind of deep love for coding. But yeah,
Yeah, it saddens me a little bit that the most beautiful code I wrote and the coding I did all happened before open source was a thing.
right.
And I think one of the things that led me from software engineering hands on to software engineering management, as I realized like the quality of this work, nobody was ever going to see it,
Yeah, yeah,
right? Like the best code I ever wrote, I think 7 people saw this code,
yeah, yeah.
you know?
I think that
So
I
there's
think
kind of a new era now.
yeah, definitely. I think that's also something that I really think makes it easier to hire great people as well. I mean, these are quite obvious points, but obviously the reason that when you get top researchers, they don't necessarily want to go and build a closed source product. It kind of has some analogies about, I guess, they want to be able to publish their research, have their authorship and so on. And, whether the code is open source, they want at least the ideas to be open. And I think with us, for example, it might be the case that for some of the engineers, maybe if they went and worked somewhere where they're doing closed products, they might get a higher salary if it was a more established company, for example. But I mean, in our case at Ivy, I think a lot of people additionally really love the fact that they're contributing to something that is open. Everything they do every day is totally there with a complete recorded history of it for everybody to engage with. It's kind of partly a public record of your own contributions and also getting, blends the boundaries between yourself and others in the community. And I've certainly been kind of obsessed and with the whole open source movement, since I got involved in it. And I think it's one of the best things to kind of, branch across different divisions and things very quickly. Yeah.
I think it's lovely in a couple of ways because there's certainly there's the conditioning of your heart that happens when you're intending generosity, right? When you're writing something and you're like,
Yeah.
okay, this might be useful for me, but it could be useful for many other people. And you can do that if you're building a local,
Yeah.
playing field for a school, right? There's all sorts of
Yeah.
ways to contribute, right? And that's kind of,
Yeah. Yeah.
makes you feel good. You're in a positive sum game, but also this sense of the exploration of boundaries of human knowledge. I was listening to this
Yeah.
wonderful interview with a gentleman named Tri Dow, who's the author of Flash Attention. And when he was co-authoring the paper, he was really focused, as it turns out. I didn't realize this until I heard the interview. Really focused on the code as a major artifact of the paper. And so the paper is going to be important, but getting the code really right is going to be super important. So what you just pointed out, this
Yeah.
rebirth of AI coming along with the sense that you want to do all these things in the open and
Yeah.
provide code to be reused along with the ideas to be reused. It's
Yeah.
attractive, right?
Yeah. No, for sure. And I think with those kind of things as well, if you can provide one really fundamental rung to the ladder that has huge implications. I mean, obviously something like flash attention, I mean, because of the prevalence of transformers right now in all of the chatbots and all of the LLMs, like this one function, getting that right instantly has a huge impact. I mean, without exaggeration, for millions of people. Like, you do this one piece of code, flash attention, then gets merged into OpenAI Triton. It then becomes the default that PyTorch use. It then becomes what OpenAI uses, what ChatGPT uses, and millions of people across the world are suddenly having a better experience because of your CUDA kernel that you did. I think that's amazing, and that's kind of only possible with open source, obviously, because it just then becomes there. It becomes democratized, and I think that's the same kind of thing when I would start. I mean, I didn't do too many, but I made a few contributions to TensorFlow and to MXNet and to PyTorch and stuff. Oh no, maybe not PyTorch, but I made a few contributions to open source repositories, and even if it's something quite small and there's a bit of C++ you've optimized, just knowing that the next time someone does a pip upgrade, they might be getting a few percentage points because of this little thing you did. I mean, as someone that's entering the space, it feels amazing. It's like, I'm part of this now. Like, I'm doing something that benefits all these people. And I think that's really the beauty of it, for sure. And actually, funnily enough, with flash attention, so I mean, Try obviously, I mean, now I think starting his own lab at Princeton, if I'm not mistaken. But the co-author as well, Dan Fu, is working with us, and we're working very, very closely on flash attention actually, and integrating that. So a piece of work that we're super excited about and quite familiar with as well.
That's cool. That's really cool. So this sort of resurgence also of open source in AI is fascinating too. On the same flash attention topic, I think I was hearing that Flash Attention 2 is getting integrated into the Red Pajama work, right? So this Llama 2 launch, giving us all hope that you can create a great open source ecosystem for ML in a really serious way with world-class transformers and training sets. So I'm curious to hear you expound a bit maybe on in this moment, what does open source data mean? Is that a meaningful question right now, or is that become too narrow? Should we be talking about open source in an even broader fashion than data?
Yeah, I that's a good question, and to be honest, the term open source data is something that I only actually personally came across recently. I know it's been a term thrown around quite a lot. I think it's a very hard thing to pinpoint what that means exactly, but I would say that
yes,
the fully open source data is where not only the data set is open, it's licensed to be used by anybody for their own training. It's maybe not just, maybe you have like a non-commercial license. If it's truly open, I think it should be truly open. And I think maybe I'm taking this question in a slightly different direction, but particularly when it comes to AI, like maybe the data isn't enough, or to say that the data is all open, but actually if you build something, I think in the case of Llama 2, actually, we're going through that paper right now. I actually live streamed a reading group on this 2 hours ago, and was presenting it on our channel. They mentioned the data, but I think what you really would need is the full algorithms for cleaning the data and explaining exactly how that data was curated and how it was fed into the model. Because saying that we use these data sets in some unclassified proportion with some unclassified filtering mechanism doesn't really make the results reproducible. So I guess the only point I would say is that saying, having open data is one thing, but when it comes to AI, if you really want it to be open source and reproducible, that kind of gap between the open data and the open source final model, ideally that the whole process of creating that model is open as well. If you really want to kind of democratize and really want people to be able to build on it, which is not, as far as I can see at least, although I'll hold my breath because I've only read the first 50% of Llama 2, but as far as I can see, it's not quite all fully open. So I think that's what I would say. Just like I think you should not only think about the data, but think about the algorithms and the processing being well transparently communicated as well. And that's then maybe truly open source model and data set.
That's really neat. So I've had the opportunity to ask that question about 55 times on this
Right.
podcast. And every single time I've asked it, I've gotten a different answer.
I'm not surprised.
Often those questions, the answers will kind of cluster into one of about three different distinctions. But you're the first person to offer a fourth distinction, which is really fascinating to me, which is reproducibility.
Yeah.
So rather than talking about open source as a quality or an attribute of the thing itself, or something that's
Yeah.
could be regulated or legislated, right? To then go back to like, why would you have it open? Well,
Yeah.
for the sake of reproducibility is quite
Yeah.
powerful,
Yeah.
super fascinating.
No, definitely. It might just be because my lens on this also comes from a researcher perspective, having done a PhD, where you would want to basically be able to reproduce results as best you can. Sometimes one of the first things you want to do is just try to take what they said they did and rerun it on your machine to kind of falsify that you can do the same thing. And also, I think you can then build on the techniques and the insights best when you have that whole thing. Yeah, anyway, but there might just be my kind of researcher lens a little bit that is the focus there, perhaps.
Well, I start to wonder if how much of that is a cognitive design center for you, because as I look at Ivy, there's a way of looking at it to say like you can reproduce anything anywhere, right?
Yeah,
To some extent, there's almost Douglas Adams Babelfish, right? This is something that could say like you've done some work over here and you can translate it into any language and take it anywhere. So I wonder how much that ends up being actually just a bit of who Daniel Lenton actually is.
well, yeah, that's a very good point. And actually, this speaks a lot to the origins of Ivy, to be honest, which was having engaged in research and worked in a lab where we would have people go and intern. I mean, we had someone intern at OpenAI, others would go to DeepMind, Boston Dynamics on the robotics, Apple, Microsoft, etc. Everybody actually, funnily enough, would seem to go to a totally new place. I don't think we had a single person go to the same place. But what that meant is then when people would come back, they would all not only be using a different framework, but be using different hardware and compiler infrastructure, given it was a robotics lab as well, like the focus very much being embedded applications, cameras, and it wasn't just spinning things up on a big GPU. So it kind of gave me a very good sense of the AI fragmentation across all levels of the stack, the frameworks, the compiler infrastructure, and the hardware. And I think reproducibility and being able to collaborate were really important. And it kind of, I suppose, planted the seed that made me feel as though things were broken. No one was really fixing them fully. And I kind of took it upon myself with a kind of pretty grandiose vision to try to do what I could to help out. But yeah, as you say, sorry, bringing it back as you say, it came first and foremost from an inherent inability to collaborate and to reproduce things and so on, which was frustrating because when you're researching, this is one of the most important things to move quickly. Yeah,
It's really neat. It reminds me in some ways of Dask, right? As a way to say like you've already written this thing. Now, do you
yeah,
want to get a lot more power out of it? But of course,
yeah,
this is now in sort of this more modern era
yeah,
of building something that can unify PyTorch and TensorFlow. You mentioned that you've
yeah,
already contributed both of those.
yeah,
NumPy. There's a lot of still artificial barriers, right, between people sharing knowledge because sometimes
yeah,
your very high dimensional, very powerful, capable knowledge is trapped in a particular framework, and so
yeah,
translatability is kind of a
yeah,
substantial gift. There must have been a lot of pretty substantial challenges, though, from the idea of like, oh, wouldn't it be wonderful if I have a magic wand that I could take things from one
yeah,
world to another? But actually building the transpiler, getting into deciding what the framework ought to be. I'd love to hear
yeah,
you just kind of walk
yeah,
through not just the inspiration, but like, what did you
yeah,
have to learn on the way, and who did you have to pull in to help you
yeah.
with some of these challenges?
So think the first thing is I had to learn a lot actually. The reality is very little that I did, either during the research in the lab or certainly my master's, which was actually in mechanical engineering. Most of my exams were about gearboxes and kind of aerodynamics, and none of it was about coding at all. So really, I certainly have no prior experience in really in compiler technology, but I'm a big believer that particularly nowadays, you can learn a lot online, and I think the ability to kind of, I guess what I learned at high school and what I learned in my degree and in my kind of during my research as well is basically like, meta learning to learn new knowledge pretty quickly without too much supervision. And I think there's amazing resources out there. I mean, the whole of LLVM and MLIR is like all open, like it's there if you want to troll through it. So I think like even though I wasn't an expert at these things ahead of time, I guess I learned to learn to a half decent standard, and I kind of then really wanted to dive into this and just kind of on my own accord just dive deep into the materials and didn't stop really. And yeah, in terms of the challenges, I mean, I guess there's two challenges. The first of which is it's just a huge engineering challenge. What we're doing is not necessarily low hanging fruit. It's not like there's a few lines of code and we provide loads of value. It's like we kind of want to think quite deeply how this is done, and that requires a lot of work because we then need to re-implement a lot of functions. So basically, just to try and explain on a high level, like there's a lot of intermediate representations.
Yeah.
In my view, the best like universal intermediate representation is quite a high level one because AI is fundamentally predicated on linear algebra, and the array API has not changed much since NumPy in 2006, and you could even trace this back to MATLAB and the predating languages to that as well. And basically, there's MapMul, there's element-wise addition, there's etc. The matrix is a pretty cornerstone representation in mathematics, and therefore in these libraries. And this just seemed like the right representation to build around and unify around to have like universality and to keep being relevant into the future. And a lot of the representations further down are very useful, but are a little bit, a bit more, a bit lower level, let's say. So it just felt like there needs to be an intermediate representation at this level to be able to quickly and easily translate across these frameworks. And that's what we did with Ivy. And in fact, we didn't do that completely in isolation. There's the array API standard from the guys at Quansight, and a lot of the the main NumPy contributors and NumFocus and SciPy, etc., all agreed on the standard. In fact, PyTorch creators TensorFlow and JAX have also got involved and agreed to this, although they're moving slowly towards the standard and won't ever fully reach it. Sorry, I'm going off a lot of tangents here. The point being, we decided let's first and foremost build everything around this standard, and then let's try to bring every single API that's out there to it. And let's have a way of taking any version of any code, including long tail code. This includes scikit-learn, pandas, NumPy. Let's find a way to take any of this and bring it into this relatively high level intermediate representation. Once we've done that, we can plug all of the compiler infrastructure into this singular docking station, and all versions of all frameworks get access to the bleeding edge stuff. I mean, as an example, OpenAI Triton is an amazing piece of compiler technology, but it's very much tightly woven into PyTorch. Now, wouldn't it be great if all of that technology was instantly available to, NumPy? I mean, and also to things like scikit-learn and pandas that you don't necessarily think of immediately, but they're huge parallel processing as well. Actually, a lot of this technology could be leveraged when you do heavy data parallel workloads and so on. So we kind of didn't take the low-hanging fruit. We were like, well, this should all be different. And like, if we just get it right at the beginning, I think with enough inertia, we can then make an impact. And the other thing, I'm answering questions you're not asking, but the final thing is a cherry on top, is like a very common thing people say, and it's a great point, is, well, isn't this just going to be like endless work? Like, aren't you just going to constantly be updating all of these functions that translate from these new frameworks to Ivy, and there's a new update and you need to catch up, and there's hundreds of functions? Isn't it going to be a nightmare? And there is some recurring maintenance work needed, but the reality is all of these frameworks have incredibly strong internal motivation to keep strong forward and backwards compatibility. They can change the underlying tech and the underlying hardware support and so on, but they don't want to change the user-facing API. If that changed on every release, every old piece of code would break. The other point to make is that we don't necessarily need full coverage to have an impact. As with most things in life, things follow the Pareto principle, where there's an exponential frequency decay. Most of the popular transformer models have like 20 functions doing all of the heavy lifting. In fact, when you look at MapMul, multi-head attention, ReLU, and element-wise addition, you've almost got everything you need for a transformer, minus a few more. So it's not like we think, well, we're going to get 300 functions added and then we can release this. Like, no, we'll work backwards from user experience and from stable APIs with really core important functions, we can get moving very quickly. And I think that's kind of to people's surprise when they first think about this, actually, a lot of the work we do is pretty much done once it's done and doesn't need to keep being updated, actually, even across version releases, because the APIs are stable, basically. I kind of answered the question you didn't ask.
That's really interesting. These are great. You're actually anticipating my questions almost psychically. A good friend of mine, Jake Luciani, just released a project he's been working on called LLMJ, which is a pure Java LLM inference engine. And it's interesting to see in this Pythonic sort of centric revolution for AI. Java has been left behind, which is ironic since we're chasing performance. So you end up having this like Python plus some hacks in C, making things faster. But most of the people using the Python don't understand the C. Most of the people who are really comfortable in C, kind of don't really respect Python. And Java is one of the most observable, tunable languages, ironically, in 2023. So one of his motivations was understand how LLM inference engines work. But two, like figure out how you can make it go faster. And his takeaway was like, he was astonished that 75% of all of the compute time was spent in dot product.
Yeah.
Right. To your point about like you only need a very small number of functions to work really, really well to make the whole thing go pretty fast. It's an insight that's born of like diving all the way down as you have and as Jake has.
Yeah, no, and this is also why. Sorry, just to give a quick shout out to DeepMind. This is also why I personally think. Sorry, I could easily go off on another tangent here, but I think that's also why it works.
No, it's fine. Stop. Like this is like literally my favorite kind of conversation. Like we're just exploring a bunch of stuff. So don't censor yourself. Don't feel apologetic. Don't have any kind of friction. Like this is super fun.
I'm a big divergent thinker. It's what I normally do. I kind of have a million thoughts at once. But what
absolutely.
What I was quickly going to say is basically that alpha tensor as well, for example, also I think this is where some of the work that DeepMind are doing on RL driven, RL broadly applied to all kinds of things is really interesting. Obviously, there's amazing works like AlphaFold and applying this to various games, AlphaGo, etc. But the alpha. I think the latest Alpha Code or Alpha Dev, I forget which one was the one that did sorting algorithm, but certainly Alpha, I forgot what it's called actually, but Alpha MapMul, whatever that one was, the one that optimized matrix multiplication. I think this kind of work is really interesting and something that makes me think about, as I'm sure many others are, is what will the compiler infrastructure look like long term? Will it be the case that eventually we go from a high-level graph that consists of mapmul at the nodes and so on, and can we bypass, MLIR, there's obviously things like XLA from Google, amazing piece of compile technology that do graph rewriting, operator fusion, quantization and so on. But is it possible that all of these are eventually implicit byproducts of a higher level loss function where the search space of assembly code, let's say, the search space of assembly code is actually explored by an RL algorithm that knows shortcuts that we can't even comprehend, in the same way that we can comprehend many of the shortcuts in chess, in alpha, in all these things. So my gut feeling is that in 10 years' time, compiler infrastructure may be replaced with a black box neural network, which is interesting because it means we go from we go from models where we don't understand what's going on mathematically, but at least we understand how it's being compiled, and we can at least write it as a sum of additions and matrix multiplications. Maybe we go from these black box networks where we don't know what's going on to literally black box assembly, where we don't even know how this replicates the maths. And I think that's what's most likely going to get the highest performance.
And black box memory also, right?
Yeah.
So there's some really interesting work done by the Google team on learned indexes.
Yeah.
Right. So you can you think of ML as being a better, a generator for better ways to lay out data. So do you want to beat a B tree? Do you want to, do you want to write a Bloom filter? Well, you can build an algorithm that will generate something that is better than a Bloom filter, more efficient, right? Matches the sparsity of the data, more effectively or whatever. So at what point do we start to go I'm not even going to try to understand it, to I'm going to have some kind of fuzzy grasp to, oh no, we're launching a rocket based on this stuff. We're going to sub-optimize and have something that's less performance because we absolutely have to understand it, right? Not just explainability, but comprehensibility and modifiability by mere humans compared to machine intelligence that are building, hyper-optimized machine implementations of our intent. It's a very strange future we're heading towards.
No, definitely. It also makes me think of one other quick point, which is, I think in the case of rockets and everything, that there's no questioning that, but just in general, how effectively That's right. It's getting a bit. I have a tendency to get pseudo philosophical. Speaking as a non philosopher, definitely emphasis on the word pseudo. But one thing that it makes me think of is that we do have a very high, we have a much higher expectation of reliability from an algorithm than we do an actual person. Of course, like people are in the loop all over the place, and we expect some of them to, you know, make mistakes, forget things, and it's fine. Like, whereas we're obviously like in the case, it's the same with self-driving cars, but we could get to a point where productivity
Yes.
could objectively be way better. But I think we will look to black box algorithms with much more fear and skepticism than we would like black box brains. I guess because of the empathetic sense, but and yeah, I mean, it's an interesting question whether that should be the case or not. I'm inclined to think we should treat them. We shouldn't expect to hold AI algorithms to such high standards necessarily if the domain isn't critical. But I can also understand why people are a bit uneasy about letting something have control that may make mistakes the same as a person does, but you know, it's something a bit different when it's an AI doing this kind of stuff or going rogue. So, yeah, I don't know. Just
Yeah,
another
we
point
don't
there.
really have a great legal or philosophical framework for like a cybernetic future, right? Where
Yeah,
there's a fuzzier boundary between agency, right? Whose agent? Was it my agent that I directed that happens to be something that's running entirely on silicon? How much
yeah,
has that been trained on my information? How much does it represent me? Can your
yeah,
agent and my agent have this interview in the future, right? Is
yeah,
that is that something that's going to be publishable?
yeah,
Like, who's going to listen to it? This is all kind of, maybe for me, this is the real singularity. Is like, once you have this
yeah,
this hybrid reality of legal entities that are taking actions more
yeah, yeah, yeah,
effectively than you do if you're only
yeah,
silicon, or if you're only
yeah,
organic, if you're only carbon. We
yeah.
don't know what the next 100 years holds. So yeah,
No, no, for sure. And you can also see that's
where
gonna
do you
like.
hope to where do you hope to go next?
So
So go
sorry,
ahead.
sorry. Also, I know we're slight victims of the delay from my bad internet, but where do I hope to go next? That's a
Oh,
great
good.
question. Um, so I guess so. There's a few things in terms of. I mean, speaking about. I mean, Ivy. Um, we've we've been thinking quite a lot about all the things that Ivy can unlock, and it's quite a. I mean, when everything gets padded out, it's a pretty universal tool, and actually, there's all kinds of different verticals that it can be applied to. And one of the big challenges is then the messaging. Like, I suppose that there needs to be a bit of a tip of the spear or something, or kind of a clear message that is resonating, rather than it can do this, it can mix and match across frameworks, it can make things faster, it can make things easier to develop, it can kind of do everything. We're kind of trying to at least like hone in on one of those a little bit to start with. And what we see as being the most valuable right now is deployment, because basically each framework out there connects to a subset of the compiler infrastructure below, and there's only more compiler companies and hardware companies coming onto the scene with new cutting edge stuff, often based on quantization or sparsification or pruning, but also just based on better compiler tech, better graph rewriting, and so on. XLA is amazing, OpenAI Triton, there's still Apache TVM, MLIR, LLVM, Mojo bringing this to a high level language with modular.
Right. Speaking of LLVM, before,
Yeah,
right, what Chris Latner's doing now, right, it has some echoes in what you're tackling with Ivy, but also a new proliferation, if not abundance, of chip designs.
yeah,
Because now the value of the AI workload is starting to push chip designers to think about things quite differently, right? Much
yeah,
more around SIMD, and
yeah,
how do you lay out, your chips
yeah,
to be able to share memory, to be able to support tiling natively, or
yeah,
or whatever, right?
yeah. Exactly. And I think that new wave of fragmentation it is in desperate need of optimization. And I think, speaking from personal experience, when you have your model that's in whatever framework, I mean, if we're talking about LLMs, more than likely it's in PyTorch. You have your model and you want to get it running as efficiently as possible on on whatever hardware. And often actually you don't even care about the actual specifics. You have, let's say, three competing metrics. You have accuracy, you want to be low, you have latency, you want to be low, and you have cost, you want to be low. But these things are inherently competing with one another because quantization drives down latency, but also drives down accuracy. I might have said you want accuracy below. I meant high. So
Yeah.
you have these things compete, and same actually is the case with cost and latency, because one of the best ways to drive down cost per API call is to batch these things together and run them on a massive TPU, and like maybe pool them all into a huge batch and run them all in one go. But if you have like asynchronous queries that all need their own very responsive reply, then probably you should quickly spin it up and send it to a GPU instantly as soon as you get the request and send it back. And that costs more, but it lowers latency. And all these three things are competing. And what you end up wanting as an end user is something that balances these things, because your application, depends on them in some customized way. And then you're left with all these options, like all these backends. Do you use PyTorch with the TensorRT backend? Do you use it with the XLA backend? Do you go on AMD or potentially Intel and run it on a CPU? Do you use various quantization techniques, sparsification, etc.? There's a handful across all levels of the stack, and it's overwhelming. And you end up just trying a few and just going with whatever there is. And that's particularly as we enter this phase, or continue to go into this phase where, like, the circle of AI development has increased. Like, very recently, a lot of people that were not AI developers, they were developers, great developers, but they're now, prompt engineers, or they're now, which is, I'm not the person that turns my nose up at them. That's great. It's really useful, but the field has increased massively. And there's a load more AI deployment accelerating at crazy speeds. And obviously, whether it's about, economic efficiency, productivity, or even just like, environmental efficiency, it's obviously, not nice to know that a lot of this is running much less efficiently than it need be. It'd be great if they could all be saving money, saving electricity, saving efficiency, etc. So this feels like the most pressing problem, like, in a way, or the one that can save the most money and have the biggest impact right now. There is development across the frameworks of these boundaries. There's plenty of people we're talking to in our community. I mean, a lot of people that still are trying to develop across the boundaries of TensorFlow, of PyTorch, of JAX, and mix and match these frameworks. And that is something we're working very hard to do and are already providing. But I think the deployment piece is perhaps the biggest area. And what we're trying to do, so again, a big answer to a simple question. What we're trying to do is really be the bridge that elevates all of these technologies. And we think that, especially technologies in open source, there's a lot of amazing stuff continuing to happen in the open source. I think, as you mentioned earlier, flash attention is a great indication that, like NVIDIA have incredible engineering teams working on optimizing every possible kernel and getting crazy performance on MLPerf all the time. But still, open source algorithms can actually do better, as they did in the case of Flash Attention 1 and now Flash Attention 2. And I think OpenAI Triton, XLA, LLVM, MLIR, there's a lot of amazing stuff in the open source, and we want to build on that. And we're quite open source focused, obviously, and we want to bring all of these technologies to the end users, but also bring maybe proprietary technologies as well to the end user in a convenient API, such that they, when they deploy their model, can get all of these explored automatically behind the scenes, and we can bring them the best that they need. If this then spins out to a business model, we're thinking of this more like the Stripe of AI or something like this, where we're taking a small percentage, but we never want to try and own your entire stack. There's too much amazing stuff going on from too many different parties. We just want to be the objective source of truth to show you the data and show you where your model would be doing best, and continue to do this as a service or something like this. This is kind of, high level, some of the areas we see IVY going into, and we really want to be a useful tool for everybody. Anybody that wants to just kind of understand this fragmented, complex space quickly and intuitively, and we're trying to be the tool that does that, I suppose.
That's really cool. I mean, there's a thin but powerful horizontal promise, right, that I'm hearing you make, which is to be the best deployment choice. And that's really interesting, because when you look at the power of NVIDIA, it is still, of course, a physical chips. And so the chips are by design, by definition, proprietary. Having been in the industry for a while, like, I'm aware of the patterns when you're releasing something new as a commercial organization, especially as a proprietary one. You kind of have to focus on the coolest, newest, edgiest, hottest things.
Yeah.
And that's where the teams will put their attention. But as users, and this is why kind of open source became something that was powerful and that mattered, we have to hang on to the oldest, cruddiest stuff that we're still relying on.
Yeah.
And not to say that open source is cruddy, far from it, but that we need to collectively, one of the open source promises, one of the 4 freedoms, right, is to be able to understand and modify the things that we depend on.
Yeah.
Now, if we can have those sources and also get the benefit of the most cutting edge hardware, even though the things that we wrote weren't hyper optimized because that stuff wasn't invented yet. Because maybe the codes we wrote were 5 years, ago, and nobody had imagined, the NVIDIA 4090 or whatever. So this idea of best, choosing your best deployment option. dynamically over time forever, right? That's a
Yeah.
really neat evergreen
Yeah.
promise to make. And if you're targeting it as intelligently as it sounds like you are at this sort of deep compiler informed approach of borrowing from everything that we've learned about IRs and
Yeah.
applying it to this particular field of use and this set
Yeah.
of mathematical operations,
Yeah.
it sounds really compelling. And the deployment is certainly where great companies get built, right? You can
Yeah.
capture people's hearts and minds in design, right, and
Yeah.
development, but
Yeah.
you're going to capture the value and share the value in deployments and
Yeah.
operations. The more toil that you can
Yeah.
take out that is normally experienced every single time you deploy,
Yeah.
if you can just make that go away every time forever,
Yeah.
it would be
Yeah.
crazy not to use you, right? So
Exactly, and that's the dream. I mean, let's see if the results live up to the hype. But this is what we're quietly confident that we can deliver this kind of experience. And I think, as you say, actually, yeah, like, I mean, without going into details, but yeah, a lot of large enterprises that we speak to have ongoing, like, legacy code problems as well. And I don't think this is a one-time problem. I think people build things, the field evolves, and they need to keep rebuilding their technology. And actually, it's all just maths. It's all just matrices and additions. And our thinking is, well, let's try to, like, solve that. And you don't need to update all your old code. At some point you can, or we can transpile it to new code. But if you want to, you can just run that old code, and we'll make sure that we provide the bindings so that it works on the new stuff. And again, that extends to frameworks that go in and out of fashion, but it also extends to, like, slightly different domains. I mean, there's not. I mean, just like MATLAB is one example. MATLAB is not like the hot, sexy framework for LLMs, like, obviously, but it is really useful and widely used by millions of engineers, and they have a neural network toolbox. And if an engineer is doing neural networks, that they're quite often using MATLAB, and this is kind of quite devoid as an ecosystem away from all of this crazy tech that makes things really, really fast on GPUs. And, like, it doesn't. And what people sometimes do is, like, one-off integrations, and okay, we're going to, like, add some long tail support for MATLAB or something. But yeah, I guess I'm, like, being a bit of an echo chamber. But
no,
our
I think
thinking
you're
is,
exactly right. I think you're exactly right because the things that we built in our industry for decades have been really focused on worlds of bits and bits,
yeah,
right? Like the first thing we did was we said, like, can we translate the paper office into a digital office, right? Can we get
yeah,
that to bits so we can do a
yeah,
lot
yeah,
of bit to bit computation, right? Can we have back offices that are banks, which are really
yeah,
numbers? And
yeah,
can we have can we have infrastructure for telecommunication companies, which is basically numbers over wires?
yeah,
So the bits to bits world have been a bit focused, but the really powerful changes in the world have to do with atoms, right? And the
yeah,
physics of atoms haven't changed a lot. My
yeah,
son's doing his PhD in nanoengineering. He spends
mm,
most of his time on the supercomputer taking Fortran codes that were written at
yeah,
Caltech 20 years ago
yeah,
and trying to upgrade them so that they'll fit onto a modern supercomputer.
yeah,
So there's a whole class of people like that who are trying to
yeah,
do material science research, who are trying to
yeah,
do
yeah,
digital biology, where
yeah,
they want to be able to bring hard science things that have been proved,
yeah,
but get them to run really fast. So that now we can run simulations so that we can
yeah,
do things 100 times instead of one time in a
yeah,
given day and kind of explore the boundary of what's possible. So
yeah,
these are
yeah,
the kinds of cases that I can imagine you well fitting into in the near
yeah.
future.
No, for sure. Another quick one there is Julia as well. I mean, just to put the cherry on top, Julia is used massively in, NASA and CERN and for physics research and etc. So, I mean, the list goes on, and yeah, we're pretty confident because, again, our IR is not, it's Python right now, but our IR is basically a mathematical function API, and this transcends languages. So, although I'll kind of obviously, that will probably be coming out later in the year, so I won't sing too much excitement about Julia and MATLAB and everything, but I'm pretty confident it'll come before too long. Yeah.
I think we have to be excited. I've got a couple closing questions for you. One
Mm.
is who do you want to know about Ivy, right? And I guess I'll ask that in two dimensions. Like who do you want to have respond to their first experience with Ivy? Maybe they're listening to our
Yeah.
podcast, they're hearing about it for the first time, maybe they're hearing about it the second or third time,
Yeah.
and they're thinking, I'm going to do something.
Yeah.
In terms of who do you want to have come and say, I could contribute to that? I want to
Yeah.
get
Yeah.
active. And then
Yeah.
who do you want to have say, oh, I can pick that up and use it today,
Yeah,
and then
yeah,
I can give them feedback, right? I can get
yeah,
hold of Daniel. I can go to
yeah,
GitHub and file
yeah,
a post or
yeah,
a
yeah.
PR to unify AI slash Ivy or what.
Yeah, no. So they're definitely overlapping, but not exactly the same set. So I guess the people that are most suited to contributing are maybe your conventional AI engineers that are used to building new neural network architectures, experimenting with architectures, training things, etc. So kind of the conventional AI or ML engineer. And if you like getting your hands dirty with like software engineering as well, to be honest, I think for those that contribute, we have really rigorous unit testing and everything, and we try to uphold pretty kind of pretty good software engineering practices and everything. So if you like to really play around with the frameworks themselves, then that's the perfect person to contribute. As far as using this, we're really trying to, and I think so far doing a half decent job at expanding into this bigger vertical, like, because really what we want to make the experience as democratized as possible. We don't want to have this be a tool that only experienced veteran engineers can make use of or understand for building models. The idea with the deployment aspect especially is that all you need is an open source model that you, for all intents and purposes, can treat as a black box. Maybe you're somebody that's stitching together something with, LangChain is this amazing thing that's, come out of nowhere and is now composing all of these kind of chatbots together and vector databases and everything. Maybe you're somebody that's entered from a kind of product perspective and are just chaining things together now with LangChain. What Ivy can do is you don't, with all of these black box AI model nodes, with one line of code, it can then run faster, and you can specify what matters to you most. Is it accuracy? Is it is it cost? Is it latency? You can balance these in your own custom valuation metrics, and then we're actually working on an integration right now with LangChain, for example, where we can recurse through this compositional chatbot, and we can then for each of those nodes optimize it, get it running quicker, potentially handle the cloud for you. We can return the binary if you'd rather handle that yourself. So we're really trying to make this. I mean, one of the central pieces on our website is with one line of code, accelerate your AI with one line of code, etc. So I think anybody that's deploying AI, even if you're not an AI engineer, we're working very hard to make Ivy provide a ton of value for you. And, certainly recommend those people to try it out. And we'd love for those people to give us feedback on their experience of using Ivy as well. Yeah.
That's really cool. The tie-in with LangChain could be the killer app for 2023 for folks who are kicking this around in adoption. I'm using LangChain, right? And it's been decades since I wrote any production code. It's just such a glorious and exciting time to experiment and learn things right now. It's just fantastic.
Exactly. Yeah. And we really want to embrace all of this amazing tech.
So I'll ask you one last question, which is, you've gotten a fairly amazing set of things done in a reasonably short amount of time, right? Obviously, you've thrown yourself, fully into mathematics and research, right? And the work that you're doing in the Dyson Robotics Lab is probably a great environment to like spur you to to need to build things fast and to attract people to build great projects.
Yeah.
Folks who are listening to this are certainly going to be inspired by like your journey so far. None of us know the future, but I suspect the future will turn out in very interesting ways for you. What advice or guidance might you offer folks who are listening, who are thinking about getting their PhD, or maybe even thinking about going back to school because of what's happening now, or trying to find a way to get more involved in these kinds of cutting edge projects?
It's a great question. Unfortunately, my thoughts on this almost sound a bit cliched, but I think they're really important. I think first of all, which is pretty general advice, is I think you should really just build what excites you. There's no way that I would be. I mean, in fact, when I started my PhD in 2016, it was at the expense of much better, more stable job offers and various things, and it wasn't because I thought AI was going to necessarily make me money or anything like this, or prestige or anything really, just because it was so exciting to me. I spent all my summers doing robotics projects. I was so deeply curious about well, it came from the brain. I was like, how the hell do we think? And this is just so cool and exciting. I'd love to learn more. I think to the extent that you can, and this is quite a privileged position. Of course, not everybody in the world has the opportunity to just follow their passions. And so, it depends. But by and large, I think if you follow your passion and you remain excited about what you're doing, then it doesn't matter how far on the outside, what your outward projection looks like of success or anything. Just as long as you're excited every day and learning, I think that's something to really strive for. And that's all I've ever done. And that's all I continue to do. The reason that I'm so happy right now really doesn't correlate with the, perceived success of Ivy and where it may or may not go. It's because every day I'm just still like scratching that curiosity itch 24/7. And if you can do that, then I think you're doing well. And the second point would be, I was going to say something I've forgotten now. We just a bit more on that. Kind of don't. Oh no, that was it. The other thing I was going to say is, I mean, we take an approach whereby we deliberately don't really pay attention to the CV. We really take everybody on a merit basis of our hires. There was one, I mean, won't name names, but of course, but there was one week where we rejected an applicant from Stanford, we rejected an applicant from MIT, and we hired somebody with no formal training, no degree, and had taught themselves on YouTube, and they're one of our best engineers. And that isn't totally rare, but that's not totally rare. A lot of our engineers, I mean, many of them do come from stellar universities, but many of them don't. And actually, I think AI and software engineering is one of the fields that thankfully is somewhat democratized in terms of online content. Now, if it's law, you can't. It's pretty much in the institutions. You need to know the right people, go to the right schools, which is a shame for like social mobility, but it's the case. Yeah. Software engineering is further along because there's so much amazing content online. There's so much open source code. Another benefit of open source code is education. Like people can just, stumble across and find it and learn about it. It's not kind of held within institutions. So I'm not saying every company takes that hiring approach, but I would also just say, like, if you can become a great developer of your own accord, and if you back yourself to do that, you will end up applying that because somebody's going to hire you for it. So I would say just back yourself to do what excites you, and don't be intimidated by other people with on the surface better CVs and stuff. Some of my advice, yeah.
That is fantastic advice. Daniel, thank you so much. It's been an inspiring conversation. I've learned a lot, and I'm actually going to go try to figure out straight away how to use Ivy and LangChain together because that's going to be fun.
Sounds good. Yeah, well, I would love to hear the feedback. We'll make sure to make that as smooth as it can be.
Absolutely.
Awesome.
Thank you so much, and good luck in your journey. And I think it's going to be an awesome one. And I'm happy to get a chance to follow it.
Likewise. Well, it was a real honor to be on the podcast. Thanks so much for inviting me. And yeah, looking forward to staying in touch.